So now what we want to take a look at, a little bit of new terminology. It's known as the right bisector. So of course, right, it talks about a right angle. Bisector is to cut in half. So the right bisector or the perpendicular, again, 90 degrees, perpendicular bisector. So that's simply a line which is perpendicular to a line segment. And divides it into two equal parts. Okay, so that's known as the right bisector or a perpendicular bisector. So, if we were to draw that perpendicular bisector, I'll approximate, I'm trying to draw a line that's at 90 degrees. Looks like it needs to be maybe a little more to the left. Not that far to the left. Anyways, you kind of get the idea. Can I go up and do? All right, so you should take your ruler and draw a line perpendicular. Imagine this is done with a ruler, and that's at 90 degrees. That's what it would sort of look like. All right, so how are we going to be able to sort of solve for questions like that? In this case, we're given triangle ABC with vertices -3, 1. Okay. -3, 1. B is 5 minus 1. And C is 9, 9. Again, this would be drawn with a ruler. All right, so that's my triangle. We're asked to determine the equation of L, the right bisector of AB. So there's going to be some line, L. I'm going to try to change the color, but it's going to be coming through, bisecting, kind of around there. Got to be at 90 degrees. So it's going to maybe look something like that. To determine the equation of this line, and then graph and label it appropriately. So this is going to be my line L. Maybe I shouldn't have done this yet because we don't, I know it's going to look approximately like that. And maybe after I've done it algebraically, I'll go in and put my points on exactly. The system doesn't seem to be working for me too well, so I'm not going to try to connect the dots with the lines in D12. So first of all, in order for this to bisect AB, that means I'm going to need to calculate the midpoint of AB. It kind of looks like it's passing at 1, 0, but we're going to need to confirm that algebraically. So first step is going to be to find the midpoint of line segment AB of that triangle. So I'm going to use the midpoint formula. The midpoint of AB, coordinates are x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. I don't know why this is undoing my work. All right, so that's my midpoint formula. So I'm going to use my coordinates A and B. This is my A and my B. I'm going to add those up, and that's going to become -3 plus 5 over 2. And then the two y values are 1 plus -1 plus -1 over 2. -3 minus 5. Oh, the computer is undoing my work. Minus 3 plus 5 is 2 over 2. 1 plus minus 1 is just 0 over 2, which simplifies to 1 comma 0. So that's my midpoint, and sure enough, that's exactly where that is. So I've kind of got that midpoint correctly. Now, what I need is, I found that midpoint, so I know where it bisects it, but I need it to be the right bisector, the perpendicular bisector. So I know that my line has got to be perpendicular to line AB. So remember that to find an equation of a line, there's two things that we need. We need a point and a slope. So we've already determined a point because that's where it bisects. So now I need to calculate the slope. Well, I can say since my line is perpendicular to this to line AB, right? Since it's perpendicular, I'm just going to say AB because AB is a segment. Since the line that I'm requiring to find is perpendicular to AB, therefore, the slope of my line is going to be the negative reciprocal of my slope of AB. So it means I'm going to need to calculate the slope of AB. My slope of AB is delta y over delta x, or y2 minus y1 over x2 minus x1. Change in y for A minus B, so I'm going to say 1 minus minus 1. Minus 3, subtract 5. One minus minus 1 is like 1 plus 1, so that becomes 2. That was a 5. This value down there is a 5. I'm just going to try to make that a little bit neater up top. One minus negative 1. So 1 subtract negative 1 is 2. Minus 3 subtract 5 is 8. Negative 8, which reduces to minus 1 over 4. I can say, therefore, my slope of my line is going to become, right, because I know that's my negative reciprocal, the slope of my line is going to be positive 4. So I've got my slope, I've got my point, so now 3 is to find the equation of my line. So I start with my slope point formula, y minus y1 equals m times x minus x1. My point y is 0, slope is 4, and my slope down here is calculated as 4, x subtract my x1 is 1. That simplifies to y equals 4x minus 4, which tells me that the y-intercept is minus 4. 1, 2, 3. So that's my y-intercept. And so my line, it's got a slope of 4 as well. So I go up 1, 2, 3, 4 over 1. So that's go to my point 1, 2, 3, 4 over 1. So this is my line. So I just kind of sketched it on there originally to kind of get a sense of what it might look like. Now that I've actually calculated that equation of the line, I can see exactly what it looks like. And before doing the question, I actually just went in and did it on Desmos. So there's my triangle ABC, my points A and B, and the equation of the line is y equals 4x minus 4. And that kind of does look like it's perpendicular. But if you had a ruler, doing it on your sheet, it should work out just fine. All right, so those are some applications of using parallel and perpendicular lines to come up with equations of lines. You've got some practice questions that I recommend that you work on. Okay, if you've got questions, let me know.